So today we're going to take a look at some of the new functionality for Geology Core 2023. This is going to be a very simple example of a faulted vein data set. So in this case, I've got my domain manager group and I've got a series of veins in my group. Now this data has been faulted, just a single fault in this scenario, so to try and keep it easy to follow, but each of these domains have been defined in both sides of the fault. So to make my fault, I have extracted points that define my fault plane, which I've then gone into the fault manager. I've defined a fault group. So we've got my bounding box, which I'm using as my constraint. And then I've got a topo as well, which I want to clip to as part of that. So I've included both of those. In this case, my 5 meter triangle size is okay, but if you've got a really large region that you're making your fault model for, it's a good idea to pick your triangle size based on what sort of distance spacing you have on the points that you're modeling and the drill holes that you're modeling. So in this case, I've added a single fault to the chronology. So just plus add a fault surface, give it a name. That's then going to create in the CAD folder, you get this fault group fault modeling. So fault group, and then it's got fault modeling after it. So it'll have the name of your group and then fault modeling. Now I'll get a container for whichever faults I've got in here. Now this will be a flat list, and I'll do another video going in a bit more depth of the fault manager itself. But in this case, I've just got one fault, and in that I've got my CAD points. So if we make those a bit bigger, you can see they're sort of running through the middle here. And if I run that and turn on the fault blocks in here, the other thing I did do is, as you can see, it's reading the CAD data from in here. If you put any structures into the little structures container that's automatically built, it's going to automatically read those as well from this folder path. In this scenario though, I'm using the global orientation. So I've just got a series of points, and I'm going to use this global orientation because I know that's around the orientation that my fault goes. So you don't have to add any structures if you don't want, but you can if you want more localized control over the shape of the fault surface that it makes. So if you're doing multiple structures, then you don't use the global control. So sort of one or the other. So if I run that, that's going to go and build my fault surface, and then it's going to build my fault blocks using that fault surface, which is going to appear under my fault modeling. So that's done. So fault modeling just has the links to the extents, which we can't sort of do much with at the moment. And then in my chronology, I've got my main fault. So if I drag that in, it's just going to drag in the final fault surface, which has been clipped to the bounding box and the topography. All right. So if I drag that in, it's a change with, this will be the same with the modeling manager for this release, but anything that's in these grey containers won't get loaded. So I can just drag the top level in, or I can drag chronology in, and it's only going to load things at that level. So you don't get all the other intermediary stuff, we just get the final surface loaded, so you don't have to nest down as much if you don't want to. And from there, then we get 2 fault blocks as well, right? So it's split on that fault. Obviously you get an unprocessed fault surface, which kind of goes further than your bounding box, which we use to kind of cut up everything. But the final fault surface is that one there. So we've got our 2 fault blocks. So from there, I'll create a new modeling manager group. So we'll come in this way, and I'm going to say it's a demo group. And I'm going to use this create faulted model option, which means I don't need to provide the bounding solid and the topography, because that's going to get read from the fault manager. I want to snap to my drill holes. Surface models, I'm going to add the chronology. Now, this is where this panel will look different because I've selected the option to create a faulted model. If I haven't, then it's just the standard vein or add surface panel. But when you turn on create faulted model, you get the fault options, and it reads the fault groups that are in your project. So I'll pick my fault group, And you've got options, so you can add surfaces that you pick on the right to all of the fault blocks. In this case, it's read that there's 2 fault blocks. Or if you wanted, you could add a surface to just particular fault blocks. All right. In this case, I'm going to add all my veins to both fault blocks. So I'll do that and model the whole domain group. But what I will do is I'll put them all into a vein network in each fault block. Then model all of those in there. So if I do that, see now we've got 2 fault blocks. Within each fault block, we've got the vein network that I defined, and then we've got our veins within each of those. Now, I know from this one, I've got a bifurcated vein in here as well called TQ3. So within each fault block, I want to add another network for TQ3. I'm going to leave this blank, so it's just empty. Put that in there. And then we can grab TQ3A and B and drop them into that. And then do the same down here. As part of my fault blocks, so I know that in fault block 2 here, TQ11 doesn't exist, so I'm going to get rid of that one because it'll yell at me. As part of that particular block, I know that TQ3, I'm going to merge to a single solid, and that TQ3 truncates against the hanging wall of TQ3B. And I know that in fault block 1, so this block, I don't actually have any of TQ3A. So I'm going to get rid of that one and still just kind of keep that merge to a single solid option to be consistent with the TQ3 network later to conjoin everything. What I might do then is now I'm going to edit the parameters for my vein. So obviously everything is going to get read in. I'm going to set this as a min-max for now, and then I'll sort of show you some new stuff with pinch outs in a second. We've got some new options for how the data gets defined as part of this modeling, and I'll show you those different options. So we'll run through it. So we'll start with the default, which is what was previously the no relimiting option. So what actually happens is it's going to generate the data to orthogonal extents of the input data. So I'll leave that as the default for now and just copy that down to everything. So I can shift click and select everything, and then I can control click to unclick the fault block, and then it will let me import everything from that first one. And so then I'll go and run that. All right. So now that that's finished, so I'll remove my fault blocks. Under modeling, we've got my demo group. So I got my fault blocks. So in each fault block, you get a chronology. So I can drag the chronology in both cases, and that's going to load all the data. Now, the only scenario you can see in here, it looks a little bit funky. Part of that is because I've got my sub-vein network. So as part of that, it actually loads, in TQ, well, it does in that one. So it's going to load that level in there as well. And then TQ3 here, I can remove those vein solids, and now it just shows me the final solid for TQ3. So as part of those settings that I used, obviously each vein's been modeled using its orthogonal extents, right? So if I get my fault blocks, so we've ended up with things being modeled independently within each fault block, right? And it's just used the orthogonal extents of each of the input data for each vein. So we can play with some of those settings if we like. And as part of that, I can, for example, now I can use this generate to bounding box extent. Now this is going to take longer because especially if you've got a really big bounding box, really big fault blocks, it's going to extrapolate or interpolate the vein surfaces and solid to the full extent of that box. We do this automatically behind the scenes if you define a truncation rule. So if you say that this vein needs to truncate against the hanging wall surface of another vein, that hanging wall surface that's used to truncate against gets generated to the full extent of the bounding box so that we can get a clean cut. So that option we can do. and it's going to get extended all the way out. So I'll show you that quickly. So you can see now we've got, if I toggle off my fault blocks, my vein solids go to the full extent of that bounding box. And this is why we can get some really nice truncations now. So again, behind the scenes, if you make a truncation rule, you're going to get one of these surfaces anyway. Your vein solid will get relimited as you've defined it to get relimited, but it'll get truncated against one of these full extent surfaces, just so that we can ensure that you get a clean cut where we need to. Now, part of the problem here though, if I hide this one, is you can see that surface extends into these drill holes up here where I don't actually have any intervals of TQ1. What we can do now in this version of Geology Core, if we go look at TQ1 in fault block 1, in the vein contacts container, we also now have this barren intercepts. So if I drag that on screen and hide my drill holes and TQ1 and my fault block, you can see we get these intercepts where there's a vein surface intersecting the drill hole, but there isn't an interval of TQ1 in that hole. So what that allows us to do now, and again, you can go and change these manually if you want. If you use the vein contacts tool, it'll allow you to ignore them or flip them or whatever you want to do with them. But what I can do in this case, so my extent limits now, I'm just going to go back to my orthogonal extent and I'll give it an extrapolation distance of 10 meters. But under the controls, rather than using min-max, I'm going to use the pinch outs option now, so then that will use my barren intercepts. So if we do that and then copy that to all the other veins and I'll rerun that. Right, so now you can see, if we hide the fault blocks, these surfaces have been pinched out where it doesn't intercept those drill holes. So it's a nice quick way to be able to clean up the extents or the limits of your veins without having to kind of digitize polygons or whatever. So that's the new barren intercepts and how they work with the pinch outs option for this release. And so I can quite quickly build up quite a complex faulted model. Obviously, it's a simple fault model in this scenario, but the veins can kind of get nice and complex as part of that. So that's just some of the new features for fault modeling in Modeling Manager and the vein models as part of this new release.